Hi friends, today we are going to understand the schematic diagram of laptop. So today we'll open a PDF file and we'll go through this PDF file and we're going to understand the schematic diagrams. So we take today Compal motherboard. This motherboard number is LA9104. This is basically used for the Dell laptops. So we are going to know about this motherboards, the components and the power flow of this model. So in this screen you can see first I'll introduce some components on this motherboard. So this one is a processor, it's called Ivy Bridge. Ivy Bridge is a third generation processor, is a planted processor. Socket is 1023. Core i3 processor have two different types. Some processors are soldered and some processors are planted, or some processor are on sockets and some processor are on solder. So this processor is a solder. The pin number is 1023. Then this is a PCH, then SIO, and then this one is a BIOS, and of course this one is a RAM slot. So we open a schematic diagram. The diagram has already downloaded. This model number is LA9014, is basically used for the Dell laptops, and this diagram is a 57-page diagram. Okay, this diagram is a 57-page diagram, and we'll open a second page. Okay, the second page is basically a block diagram of laptop. This is called a block diagram. This square is called the processor. The processor is Ivy Bridge BGA1023 CPU socket, and then this one is a PCH HM76. Then this one is called the SIO KB9012. It's called a KBC. KBC means the keyboard controller. It's called the SIO, and these are the BIOS. It's called a SPI ROM. It's connected to the PCH, and this part is called the RAM. It's connected to the processor. Okay, now this diagram is a 57-page diagram, and different page for different department. It's like the CPU information is mentioned on page number 5 to 10. Then PCH information is there on page number 13 to 20. Then SI information on page number 39. BIOS information on page number 13. It's like that. Then network for 32. It's like that. It's a different pages for the different stage. Now we are going to learn the power sequence, like when I connect the adapter and how the power flows. So you can see here there are two input. Here you can see there are two input. This is adapter, and this one is a battery. And this section which handles this adapter and battery, this section is called the voltage section. So it's called the battery charging section. So we'll first learn this voltage section and battery charging section, and then we'll go always voltage, and then we'll see a SIO sections where the laptops turn on. So we'll go back again to this PDF file, my adapter page on page number 45. So I came on the page number 45. Okay, so this one is my adapter input. This one is my adapter input. I really write here AD plus, and this one is my battery input. So there are two inputs. One is this, and another is this. Okay, so my adapter voltage goes from here, and this voltage is called the V in voltages. It's supposed to be a 19 volt. Okay, now we'll go to the next stage, that is page number 46. The page number 46 is my battery adapter and charging sections. Now my 19 volt comes here, this is V in, and these are the MOSFET. Okay, so my power will travel from this MOSFET and comes across this resistor. This resistor is called the current sensing resistor. Here I supposed to get a 19 volt. Okay, and now the next is, in MOSFET there is a mention, is called that there are two numbers on the MOSFET. One is called the PQ100. The PQ100 is called the location number. It's called the location which is printed on the motherboard. It's called the location. It's locate. And the next, in the below of that, there is a mention A04407A. That is a MOSFET number. Okay, so this one is called the MOSFET number, and this one is called the location number. So my voltage will travel from PQ100 to PQ101, and then it's reached to 102, and then spread entire the motherboard. So if now how this voltage will be handled, so we're going to learn that. Now here is a chip. This chip's location is PU100, and the chip number is ISL 88731. This is a chip number. This is responsible for adapter in battery charging section. Now when I connect the adapter, at that time, on the pin number 22, it's called the DC in. This pin. Here is a 19 volt, and this 19 volt come on this pin, on pin number 22. It's called a DC in. That is power to need to this chips to work. The next signal is called the AC in, that is adapter current in. Here is a current divider. There are two resistors. One is this resistor and another is this resistor. So current divider resistor. So here voltage will generate something like 3.4 or something. So here that is generate at pin number 2. When the voltage will develop at pin number 2, at that time this chip will come to know that adapter current is present. Okay, and after that he send out one signal that is called ACOK signal out at pin number 13, and this signal goes to the SIO AC in, and after that he trigger this two MOSFET, like see, you can see in this area AC in, it's come from here. So it's trigger this MOSFET and this MOSFET also, and after that with voltage which was halt here, that will travel from here to here to here to here. So in this case we'll see how the voltage will travel. If so, this is my first test point. I should get voltage here at this current sensing resistor. The location is a PR102, and if this voltage is not coming at this point, that means the problem either one of this two MOSFETs open, or this chip is not triggering to this MOSFET, or else this chip is not getting the AC in signal. The next is if my adapter is not working on the battery. Okay, if the battery is okay, but still when I remove the adapter, if the laptop is turned off, then this MOSFET is responsible, because my battery connector is this, and voltage will travel from here to here. This is a P channel MOSFET. When the voltage is absent over here, this is a V in voltage, 19 voltage is here. When there is a 19 voltage, at that time this MOSFET is disconnected, and when the voltage becomes 0 at this V in pin, then this MOSFET gets short and the battery voltage will travel from here to here, and this is called the V in voltage. Okay, so the next thing is these are the two MOSFET which is responsible for to charge the MOSFET for charging purpose. Their location is PQ108 and PQ110, and then this is a coil PL100, then this again the PR121 resistor, current sensing resistor, and it goes out for the charging the battery and controlled by this chip. When the adapter voltage is absent, at that time SIO communicate with this chip via SM bus. These are the 2 points for the SM bus. You can check this 2 point by using oscilloscope. You should get 3 volt pulses at this point. This is called SCL and SDA. SCL means clock, SM data clock, and SDA means SM data. So these are the 2 pins, and when there is adapter voltage is absent, when this adapter voltage is present, at that time SIO communicate and start triggering this two MOSFET, upper MOSFET and the lower MOSFET, and the voltage generated here. That voltage is supposed to be a 10.8 volt for charging purpose approximately. So in this way this circuit work. We can see on this actual board. So this is my adapter input and this is my battery input. The voltage will travel from this MOSFET to this MOSFET, and from here this is my current sensing resistor. So here I should get a 19 volt. Okay, so if it is not coming, then the possible fault could be this MOSFET or this voltage chip or this voltage chip. Okay, now we'll go to the next page. Come back again to the diagram. When the voltage passes to this resistor, current sensing resistor, it goes to the different sections, but only one section will work at this time. This section is called always voltage. That is on page number 47. This section is called the always voltage section. Always voltage section means this voltage is generated before power on, and this section there are 4 departments, 2 linear regulator and 2 pulse width modulator. There is one chip. This chip is called, location is a PU200 and the chip number is called RT8205. This RT8205 have a 4 section, 2 linear regulator. First of all, he need the power. So he get the power, that is V in voltage or 19 voltage at this V in pin, at pin number 16, that is 19 volt. And once he received this 19 volt, He have a two department. This is called the linear regulator. So once he received this power, he send out a linear regulator, send out one voltage, that is called a VRG5, pin number 17, a 5 volt, and then another voltage is called a VRG3 at pin number 8, that is a 3 volt. This is voltage is called a 3 volt regulator, linear regulator. So this 3 volt linear regulator goes basically to the SIO to turn on the SIO. Now the next is this chip have two more sections. This is called the pulse width modulator. But to turn on this pulse width modulator, these chips require one enable signal. Pin number 13 is his enable pin. He should get a 3 volt at here. So once he received this enable signal, he started triggering. These are the two MOSFET here. MOSFET location is a PU203 and PQ205. So these are UG means upper gate, LG means lower gate. So this chip started triggering this two MOSFET, and here is my 19 volt. It started chopping at this junction and is reached to this coil. Coil location is a PL201, and from PL201 the smooth DC voltage gathered across this capacitor PC20213, and 5 always voltage will generate at this point. The same things happen on the left hand side also. Here also two MOSFET. The location is PQ202, then PQ204, triggered by these chips, okay, on the gate, and again this coil PL200, and from coil out it reached to this PC202 at this capacitor, and 3 volt generate at this junction. So in this way 3 volt and 5 volt comes out from this sections, and then if this particular section, this entire section is okay, after that this chip will generate one signal that is called a P good signal, that is a power good signal or power okay signal at pin number 3. If you receive a 3 volt at pin number 23, that means this entire section is working fine. So in this way we seen how this section work. Now we'll go to the SIO page on page number 40. So this is my SIO. The SIO location is PE1, and the chip number is KB9012. KB9012 is a SIO's number. We'll see in the diagram here. This one is my SIO, KB9012, and this one is pin number 1, 32 number, 33, 64, 96 and 128. It goes anti-clockwise from here to here to here and then here. Now we again came back to the diagram, on the circuit diagram on the SIO page, and this SIO is a 128 pin chip, and now we are going to see only those pin which is responsible for power on. So what are the pins we have to check if my laptop is dead So first of all we'll check a power. SIO need a power. Last screen we have seen 3 volt generated by always voltage section, and that 3 volt always, this 3 volt always comes here at the SIO pin number 9, pin number 22, pin number 33. Any of this pin you can check this voltages. Once this chips received this supply, after 10 millisecond this chip should get another signal that is called the EC reset, the reset signal for the SIO. So on the left hand side there is one pin, pin number 37. You can see here pin number 37, and this pin is called the EC reset. The EC reset signal generated by RC circuit. So here is already 3 volt is given and connected to one resistor, then this junction, and again there is a capacitor and goes to the ground. This is called the RC circuit to generate a delay. So this RC circuit generate a EC reset. It generate a 3 volt at this point, and once SIO received this 3 volt, it generate comes out from the reset, he ready to work. The next is now my SIO is ready to work. Now I have to press the on off button, I have to press a power button. My power button on pin number 114, pin number 114. So you can see here is return on off, pin number 114. Here I should get a 3 volt, but when I press a power button at that time it goes to 0, and again I release this button, it come back to 3 volt. That means a 303 pulse should come at this pin. I have to connect multimeter over here, press a power button, it's become a 0, release the button, come back to 3. So if it is not coming like that, then possible fault could be my switch is not working, or maybe the cable is not working, something like that. So you have to check in this way. Now if this variation is there at pin number 114, then the next signal you have to check. There are 2 signals you have to check. That is a post power button, or it's called the digital power button, and RSM RST. So first we have to check the RSM RST. RSM RST on pin number here. RSM RST on pin number 100. This one is my RSM RST. When I press the power button at this pin number 100 RSM RST, I should get a 3 volt. As soon as it was a 0 volt before power on button, but when I press a button I should get a 3 volt here. If I am not getting 3 volt after pressing a power button, then there are maybe the 2 fault. Either my SIO may be faulty or the EC bias may be corrupt. So either I have to flash a EC bias first. If the problem not solved, then I have to replace SIO. So if this variation is there, if when I press a power button RSM RST comes like a 3 volt appear on this pin, that means my SIO is okay. The next signal I have to check the PM power button. The PM power button is on 106. You can see in 106 pin is called a PBTN out. This is called a post power button to a PCH. Here, like in power button, here also I should get a variation like a 303 volt variation should be there at this pin. If the variation is not there, then the possible fault could be SIO or EC bias. Now the next thing is that this both the signal given to the PCH. Now the time to PCH to work out. Now to PCH has to respond. No, now which are the signals we have to check, and these signals are SLP S3 and SLP S4. You can see on pin number 6, this is my pin number 6, it's called PM SLP S3. When I press a power button, at that time here I supposed to get a 3 volt, and same way here on right hand side SLP S4 pin number 127, here also I should get a 3 volt, and this both the signal coming from the PCH side. Now if this voltage not appear at this pin, suppose it's remain a 0 volt, then the possible fault could be a PCH. So you have to check a PCH, either you have to replace a PCH, it's like that. So SLP3 and SLP4 voltage should be appear on the pin SIO. Once SIO received this both the signal SLP3 and SLP4, he ready to turn on the laptop, and what he do is he start sending a signal called SUSP, sys-on and VR-on. He ready to first is turn on SUSP, that is called a suspend on, then the next signal is turn on the system on, and the next he turn on the VR on, that is called a CPU on signal. This 3 pin we have to check. So SUSP signal you can see on this side 116. After pressing a power button we should get 3 volt at this pin. Then pin number 95 system on, this pin 95 I should get a 3 volt here, and then finally 121 VR on, I should get a 3 volt here. But before VR on, SIO should get one signal that is called a power good signal. This pin SA power good signal. When the SIO turn on this 2 signal SUSP and system on, then suspend voltage and system voltage like 3.3 suspend, 5 volt suspend, 1.8, 1.5, 1.05, all the voltage will turn on, and then SIO received one signal that is called a SA power good at pin number 108. This is acknowledged to the SIO saying that all rest of the voltage are okay. Now you ready to turn on the CPU core, and once SIO received this signal SA power good, after that he turn on this VR on signal. See in pin number 121 VR on signal. Once SIO send out this VR on signal, he got the next signal is called the VRM power good, and after VRM power good SIO will generate a last signal that is called PCH power OK. PCH power OK at pin number 32. Here I should get a 3 volt. The PCH power OK send out from the SIO, that means your all powers planes are okay, all system power get the power, and now he send this signal to the PCH, and then PCH generate a PLT reset signal, that is called a platform reset signal, and this platform reset signal we can check on pin number pin number 13, this is called a PLT reset signal from PCH, and in this way my all power planes started functioning. So in this way we learn how this we have to check a schematic diagram. So thank you very much.